Assalamualaikum and hello. Let's continue with the second part of this chapter where we are going to learn in this video about oxidation number. So first thing first, what is oxidation number? So for your information, oxidation number is the total number of electrons that an atom either gains or loses in order to form a chemical bond with another atom. So that is the definition of oxidation number. So how you want to determine the oxidation number for each element given in the chemical formula. So let's get on with it. Alright, in order for us to determine the oxidation number for any elements in a given chemical formula, we have to follow a few rules in order to get the correct answer. So we go to the first rule, which is elementary forms. So what does it mean from here? It means that as an atom or a diatomic molecule, you have to know that the oxidation number is always 0. And when we want to write our answer, we have to write as a number. Maksudnya kena tulis dalam bentuk nilai. So 0, which means kita akan tulis as in 0, like that. So, I got a few examples. For example, saya ada example sodium atom, magnesium atom, and I also got a few molecules, which means in this case is diatomic molecule, Br2, O2, and also Cl2. So, all of these adalah free element as an atom ataupun a diatomic molecule. So how you want to determine the oxidation number? Remember, it will be always 0. So you want to put it as your answer in this form, 0. Same for all of them. So this is what it means from the first rule. Next, we go to the second rule. So for the second rule, it will apply to group 1 and group 2 elements. As you've heard before, group 1 and group 2 elements are metals, which means that their oxidation number is equal to the charge of the ion, because metal is more favored to donate the electrons. So that's why group 1 and group 2, there will be a positive sign for the charge. So how you want to determine for group 1 elements, it will always be positive 1. And for group 2 element, it will be always positive 2. So this is the value that you have to memorize only for group 1, positive 1, positive 2 for group 2 elements. So I give you a few examples. So I got Na+, Mg2+, I got K+, and Ca2+. So this is how you write as an ion. But in order for you to write your answer for the oxidation number, you have to put the value. But please remember, don't forget to put the sign, either positive or negative sign. So in this case, it will always be positive sign. So you have to put the positive sign in front of the number. So for example, I got Na+, the charge will be 1+. But when you want to write it down, you have to put positive 1. Okay, for example, I got Mg2+, so the charge you put as an ion is 2+. Nilai nombor 2 tu dekat depan awak punya simbol plus. Tapi as a oxidation number, kita kena letak sign positif tu di hadapan nombor. So it's going to be Mg2+. Okay, and also the same for Ca2+, it will be positive 2. Alright, let's go to the third rule. For the third rule, it will apply to monoatomic ions. So how? For monoatomic ion, their oxidation number is equal to the charge of the ion. So for example, I have a few monoatomic ions here. And my first example is O2 minus. So how I want to determine the oxidation number for O2 minus? O2 minus, the charge is 2 minus. But when you want to put the value for oxidation number, sign negatif ni kena letak di hadapan nilai awak. So it will be negative 2. Same case for Al3+. Sign positif akan berada di hadapan. So it's going to be positive 3. And same as Mg2+, is going to be positive 2. And S2- is going to be negative 2. So itu cara untuk awak tulis oxidation number for monoatomic ion. Rule number 3. Next one, let's go to rule number 4, which in this case, we are going to use only for halogens. So how to do that? You have to know that sometimes we use different halogens in our example. But one thing that you have to remember that the oxidation number for halogens always negative 1. Why? Because halogen dia ada 7 valence electron. So in order for it to achieve the stability, halogen akan accept 1 electron. So that's why when it accepts 1 electron, is going to be the charge negative 1. So one thing that you have to realize that you have to take note, halogen will have positive number when it combines with oxygen. So ini adalah exceptional case that you have to know. So I got a few example here. For example, I got fluorine in NaF. So I want to get the oxidation number for fluorine in NaF. So saya tak nak oxidation number for Na. Saya nak oxidation number untuk fluorine dalam compound NaF. So how to determine that? Dia memang akan sentiasa negative 1. Same here for Cl in HCl. So saya nak oxidation number for Cl sahaja. So elemen Cl mempunyai oxidation number negative 1 as well. But I got one more case where I want to determine the oxidation number for Cl in Cl2O7. And in this case, as you realize here, it is an exceptional case where, as I mentioned before, kalau halogen dia combine dengan oxygen, nilai oxidation dia akan berubah menjadi positive value. Dan dalam case ini, the answer is positive 7. So let's get on with the rule number 5, where we are going to apply for hydrogen. So hydrogen, H atom, has an oxidation number of positive 1. So it will always be positive 1. But ada exceptional case when your hydrogen combine with metal. Dan kita panggil compound itu sebagai metal hydrides. Di mana metal hydrides, your hydrogen has oxidation negative 1. It's not positive 1 anymore. So mari kita cuba a few examples. I got oxidation number for hydrogen in HCl. So saya lihat H dia combine dengan chlorine. So chlorine adalah non-metal. So tak jadi masalah. It will always be positive 1. Next case, I want to determine the oxidation number for hydrogen in NaH. And as you can see here, H combined with Na. And sodium is a metal. So this is what we have to apply, exceptional case for metal hydrides, where the oxidation number is not going to be positive 1 anymore. It's going to be negative 1. And same with the last case, I got hydrogen in MgH2. As you know, magnesium is a metal. So, ini adalah exceptional case for metal hydrides. And of course, the oxidation number is going to be -1. So, itu adalah rule number 5. Let's go to rule number 6, where in this rule, we are going to learn where oxygen always has oxidation number of -2. So, what you have to understand, dalam apa-apa compound pun, oxygen ada oxidation number -2. Itu sahaja. So, I got few example. Oxygen in MgO. So, the value will be -2. Same case as I got oxygen in water. The value for the oxidation number is also -2. So, for you to conclude so far, benda yang awak kena ingat, halogen always -1. Hydrogen always +1. And oxygen always -2. But starting from rule number 4, halogen, hydrogen, oxygen, ada a few exceptional case yang awak kena lihat. So, let's get on with rule number 6, oxygen, still at the same rule. Dia juga mempunyai exceptional case, where ada 2 exceptional case yang awak kena lihat di sini. The first one adalah in peroxides. So, when you have peroxide usually dia punya formula adalah ROOR. So, R can be alkyl group. So, how you want to determine the oxidation number when oxygen exists in peroxide? The oxidation number is -1. For example, saya ada oxygen in H2O2. So, kalau ikutkan form ROOR ni, sebenarnya kita ada HOOH. So, this is peroxide. And the value will be -1. So, itu exceptional case yang pertama untuk oxygen. Next one adalah exceptional case yang kedua, di mana apabila oxygen combine with fluorine, dia akan mempunyai nilai positif. Sebab originally dia adalah -2. So, nilai dia adalah negative sign. Sekarang bila dia combine dengan fluorine, it will has positive oxidation number. So, dalam case ini, I got oxygen in OF2. So, the value will be +2. So, itu adalah untuk rule number 7. Now, kita akan masuk rule seterusnya, rule number 8, applicable for neutral molecule. So, how you want to determine in the neutral molecule the oxidation number? Satu benda yang awak kena faham, neutral molecule adalah di mana kita ada summation of all atoms, which means kita akan campur semua bilangan oxidation number untuk all atoms. Dan nilai hasil tambah semuanya akan jadi 0. So, for example, saya nak awak tentukan oxidation number for any compounds, it will be always 0. So, for example, I got H2O. So, the whole this summation of hydrogen, oxidation number untuk hydrogen, oxidation number untuk oxygen, nilai tambah semuanya akan jadi 0. Itu maksud daripada rule number 8. Same case kalau diberi HCl, awak juga akan tambah oxidation number untuk hydrogen dan chlorine, awak akan dapat 0. Sebab dia adalah neutral molecule, dia tak ada charge. Okay? Sebab kalau dia ada charge, dia bukan lagi molecule, dia dah jadi ion. Okay, now I got one more example. saya ada KMnO4, the value will be 0 as well. So, macam mana nilai 0 ni boleh dapat? Alright, how you want to do that? For example, I have HCl. So, the summation for H and Cl's oxidation number is going to be 0 kerana dia adalah neutral molecule. But how you can determine that? We know as general, hydrogen always positive 1. So, I have positive 1. And then, halogen, which is my chlorine here, it will always be negative 1. So, saya tambah dengan negative 1. So, bila saya tambah total ini, saya akan dapat 0. So, that is how you want to prove the neutral molecule should be always 0. Okay, next one, kita go to rule number 9. So, this is the last rule. Okay, this last rule adalah untuk polyatomic ions. Di mana polyatomic ions, total oxidation number for all atoms that made up of polyatomic ion mesti equal to the net charge of the ion. So, for example, saya ada MnO4. MnO4 minus, nilai oxidation number for the whole MnO4 minus adalah mengikut charge di sini, iaitu negative 1. Saya ada case Cr2O7 2 minus. So, how I want to determine the oxidation number for this polyatomic ion? Dia mengikut charge di sini, 2 minus. Tapi bila kita tulis, sign negatif akan berada di hadapan nombor. So, dia akan jadi negative 2. And same case for NO3 minus. Charge dia adalah negative 1 negative. So, nilai dia akan jadi negative 1. So, how this number kita nak prove? Kita akan apply benda yang kita belajar daripada rule number 1 sampai rule number 8. Tapi taklah semua. Apa yang awak perlu faham, I got NO3 minus here. So, I use my example di mana summation for all oxidation number for all elements. Dalam kes ini, positive 5 untuk nitrogen. Negative 2 adalah untuk oksigen. Dan oksigen ada 3, sebab tu saya darab dengan 3. Nilai dia saya akan dapat negative 1. This is how I want to prove whether my oxidation number for NO3 minus is same with this or not. So, as you can see here, it's same. So, this is how you want to calculate. So, now, same case, I got one last example di mana saya berikan awak satu contoh. Saya minta awak untuk tentukan oxidation number for chromium in Cr2O7 2 minus. So, how you want to determine? Saya mahu hanya untuk chromium sahaja. Saya tak nak pun untuk oksigen. Dan sekiranya awak lihat di sini, saya mahu untuk satu sahaja Cr, bukannya 2. Di sini ada 2. So, saya hanya mahu satu sahaja. So, how I want to do that? Saya akan tentukan semua oxidation number untuk semua elemen selain chromium. Sebab chromium akan jadi saya punya unknown. So, first thing first, tulis dulu formula untuk Cr2O7 2 minus equals to, case ini adalah rule number 9 kita akan guna untuk polyatomic ion. Dia akan bersamaan dengan charge yang ada di sini, iaitu 2 minus. So, dia akan jadi negative 2. And the next one, saya akan ceraikan. So, bila saya ceraikan, saya akan dapat 2 Cr plus 7. Dan 2 Cr ni merujuk kepada 2 chromium atom. Dan plus dengan 7 sebab hasil tambah. 7 ini darab dengan negative 2. Kenapa negative 2 saya ganti di sini? Ini adalah oxidation number untuk oksigen. So, ingat tadi saya suruh hafal secara general. So, ini adalah general oxidation number for oxygen. And then, equals to negative 2. Still same. So, how I want to calculate my unknown is 2CR. So, saya bawa lah 7 times negative 2 ke sebelah sana. So, do your maths here. You will have 2CR equals to positive 12. Please, jangan lupa letak positif sebab positif di sini tak sama dengan maksud dalam matematik. Positif di sini bermaksud dia donates electron. Okay, sebab tu awak kena bawa positif until the end. And now, I want to calculate for 1 CR sahaja. So, how to do that? 2 here, awak kena divide lah. So, that's why you will have oxidation state for chromium in Cr2O72 minus is positive 6. And for your extra info, chromium adalah transition metal. Di mana transition metal ni dia ada warna yang yang sangat cantik dan sangat berpelbagai lah. Betul ke BM saya tu? Dia ada warna yang sangat banyak. So that's why different oxidation state akan menunjukkan different color. So as you can see here, positive 6 color dia adalah orange. And positive 3 warnanya hijau. Dan positive 2 adalah warnanya biru. So that's all for oxidation number. I hope you're clear and try to do the exercise. It's very easy when you do the exercise so that awak boleh tahu contoh soalan dan style soalan yang akan tanya. Have a go for this exercise. Try this 1.0 and you can see actually how far you understand my explanation from the initial part of this video. And that's all from me. Thanks for watching and I'll see you in the next part in the next video. So bye.